Hello, everybody. Welcome to today's live broadcast. During today's webinar, we'll be exploring how to simplify sample preparation for cannabis analysis with thermal desorption. I'm Lauren Armstrong, Marketing Director for Quantum Analytics, and I'll be your moderator for today's event. A quick note about Quantum Analytics. We are a value-added turnkey solutions provider offering an array of customized instrument financing solutions combined with technical services, installation, training, and product support. Quantum Analytics is proud to be a sales and service provider for Marks International thermal desorption products, and we are very excited to be spotlighting their products and capabilities during today's session. Which brings me to our webinar presenter, Dr. David Weevil. David is the Thermal Desorption Applications Manager at Marks International. After completing his PhD in atmospheric chemistry, he worked in a drugs of abuse testing lab before joining Marks International at their headquarters just outside of Cardiff in the UK. In that time, David has worked within technical support and service teams in the UK before the move to the US in his current role. All right, so as a guest, you'll receive a link to this recorded webinar in your email when it becomes available. This webinar, including Q&A, will last about 45 minutes. Type your questions at any time into the text box in the question module that you see on the right side of the screen. We've also decided to switch things up a bit with this webinar, and we'll be asking a few poll questions. These aren't meant to test you, don't worry, but they'll give us some idea of the background of our guests and the familiarity with the subject matter. When it's time for a poll question, I'll read the question aloud and give you all a few seconds to answer. Then I'll read the results and pass the mic back over to David. All right, well, this ends our introduction. So without further delay, I present to you Dr. David Weevil.
Thank you, Lauren. Hello, everybody. Thank you for joining us. Hope everyone's staying safe and sane under the current circumstances. So today we're going to talk through some of the work we've been doing using Marks thermal desorption for the cannabis analysis. So let's start with the introduction to who are Marks International. So we are specialist manufacturers of sampling and analysis instruments for VOCs and SVOCs. So these are volatile organic compounds and semi-volatile organic compounds for a wide variety of different matrices. We provide design and manufacture the pre-concentration instruments in the UK in our headquarters, as Lauren was saying, just outside Cardiff in the UK, and a range of sampling accessories as well that include sorbent tubes and various other sampling devices. Marks has over 200 direct employees throughout the world, and we're currently serving over 68 countries through our global distributors. We have centers of excellence based in our headquarters in the UK, in Sacramento, California, here in the US, also in Germany, China, and Canada as well. So when we talk about cannabis, what we see in the news tends to focus on health concerns. So of late, there's been the issues with the lung injuries associated with the use of illicit vape pens and products. There's concerns over the safety of edible cannabis products as well. Then on the other side, we also have people that are trying to develop and differentiate themselves in the market. So the ways that people are adding particular terpenes, for example, not just for flavor or smell profiles, but to actually give potential health benefits. And again, this becomes important when people are trying to differentiate themselves in a very large and growing market. So we'll touch on some of these points in this presentation as well. So cannabis itself, as we know, comes in a wide variety of different forms. And kind of in the modern market, the edibles and the vaping are becoming increasingly popular. So in response to this, in the states where cannabis is legal, we have a series of standardized methods, which are looking for things like residual solvents, heavy metals, pesticides, the various cannabinoids, etc. And one aspect that doesn't seem to be very well harmonized across the market right now is the testing protocol for terpenes and terpenoids. So these are these flavor, smell, and potential health benefit compounds. The different target lists we look at may range between 20 and 42 terpenes. So one of the things we'll touch on today is just that's only a small tip of the iceberg of the number of these compounds that are actually present in the materials and what we can do to address those. So as Lauren alluded to, we'll start off with a quick survey Just to find out from the people that are joining us online, which part of the cannabis industry are you actually involved in? I'll pass back to Lauren.
Fantastic. Thank you, David. As he said, now's our time for the first poll question. What aspect of the cannabis industry are you interested in? Select one or more of the following from growing, extractions, product manufacturing, laboratory testing, regulatory methods. Please select the answer that best describes you. And while those answers are coming in, I'd like to remind everyone that if you have a question for David, please type it into the question module that you see at the GoToWebinar control panel. David will be answering those questions at the end of the webinar. All right, I'm going to go ahead and close that poll. I see there's a couple more responses coming in. I'm going to go ahead and close it, and let's share some of those results. So it looks like laboratory testing, very heavily, heavy interest in this, followed by regulatory methods and extractions. All right, so David, I think we'll pass it back to you.
Thanks, Lauren. That's very interesting to learn people are working in the lab. So we've kind of got a little bit for everybody in this presentation. So we'll go through and discuss some of the results. So the recent testing we've been doing has been looking at cannabis itself and also some of the CBD containing products as well, and how we can analyze these with thermal desorption. So what I've done is I've broken them up into two rough classes. So there would be the raw product testing. So this we've done with whole cannabis flower, looking at analysis with thermal desorption, and then comparing it to some more conventional solvent extraction techniques. Looking at the terpene analysis for more challenging matrices, so the sticky vape liquids, the edibles, things like the gummies, brownies, and the oils and tinctures as well, and how we can use thermal desorption in these areas. And then again, something that's a little bit unique for the thermal desorption is ability to test kind of as consumed testing of these products. So we've looked at the dry vaping vaporizer sampling of the cannabis flower, the vape pen samplings, and then also how we can apply thermal desorption for air monitoring in sample grow rooms and smoking rooms as well. So we can take a look at each of these through this presentation and see what can be done with thermal desorption. But let's first start off with a little introduction to thermal desorption. So thermal desorption is an incredibly versatile pre-concentration technique for gas chromatography. And we've just got a little summary here of the various different mark sampling products that we have. I've highlighted in the green boxes the techniques we're going to be focusing on in this presentation. So pumping onto sorbent tubes, direct emissions from solids by direct desorption, and then also sorptive extraction of the headspace of some of these products as well. In each of these cases, the sample is either placed into an empty tube or a sorbent-packed tube where we collect the volatiles. That is then run inside the thermal desorption system, where it's transferred to a secondary focusing trap before injection to the GC and GCMS for analysis. The Marks product I want to highlight in this presentation is our Marks TD100XR thermal desorption system. So this is an automated system that allows us the ability to run up to 100 sample tubes, automated and cryogen free. So there's no cryogen needed in our systems. Another unique feature of our system is with the one system, we have this very, very large application versatility. So we can sample compounds all the way down to propane and propene in volatility, compounds that have sub-zero boiling points, all the way through to much heavier semi-volatiles, compounds that have boiling points in excess of 500 degrees C. Within this range, we're also including reactive and thermally labile species as well. So polar compounds, nitrogen-containing compounds, sulfur compounds. These can all be done on the Marks system. The system provides extra confidence in our results for the ability to do quantitative sample recollection, which is something we'll talk about a little later in this presentation. We have a very wide concentration range that we can run over as well. The mass flow controllers that control the splits within the thermal desorber allow us to use high splits or completely splitless, allowing us from percentage level concentrations down to sub-PPT levels. Other features of the system as well is the system installs to pretty much any GCMS. It's compatible across the whole range of Agilent GCs from the 5890 all the way through to the modern 8890 as well. We have barcoding and RFID tagging capability of the tubes as well for sample tracking. We're fully method compliant with all the standard thermal desorption methods, so in terms of leak testing, water management, and addition of internal standards. And then we also have our patented diff lock technology, which allows us to safely and reliably store our samples in the auto sampler ready for running. So before we go into a bit more detail about thermal desorption, I think we'll do another poll again. So this time we'll ask the question of, have you heard of or actually used thermal desorption before?
Fantastic. All right, so this is our second poll question. Are you familiar with thermal desorption? Select one of the following. Either no, I've never heard of it, I've heard of it, but don't really know what it is, I've heard of it and have a little knowledge, yes, I've used it in the past, or yes, it is a technique I use frequently. Please select the answer that best describes you. While those answers are coming in, I'd like to remind everyone again that if you have a question for David, you can go ahead and type it into the question module. You see it, the GoToWebinar control panel. David will be answering those questions at the end of the webinar. All right, I'm going to give it a couple more seconds for the answers to come in, and looks like we're about done. I'm going to share the results. So it looks like we're kind of in the middle of the road here. Just a little over the majority have heard of it and have a little bit of knowledge, but then it's followed by I've heard of it but don't really know what it is. So David, this is a great opportunity to answer some of those questions.
Awesome. Thank you, Lauren. That's fairly typical in the market. I would say that thermal desorption is a very useful technique. People might have heard of it before, but yeah, it's by no means that commonly used, surprisingly. So let's have a look at how the workflow would look for using a thermal desorption system. And this is really one of the key benefits of the thermal desorption, as well as its great sensitivity, automation capabilities, is the fact that there's really very minimal sample preparation required. So in this example, we're going to be looking at the first of those raw product tests. So here we're going to be looking at sampling the whole flower by what we call direct desorption, direct thermal desorption. So what we do is we have an empty glass thermal desorption tube. We weigh out a mass of the flour, place that inside the tube. We use plugs of quartz wool to hold it in place. We fit the auto sampler diff lock caps, place it inside one of the 100 positions in the auto sampler, and then we just run the sample and into the GCMS. So very, very minimal sample preparation here. How the actual thermal dissolver then works is, so we have our sample tube inside the auto sampler. As the name implies, thermal desorption, we heat up the sample tube. That could be a solvent containing tube, or it can be the empty tube with our product inside. There's a flow of gas, inert carrier gas, that's coming through that tube while we're heating it. So what's happening is basically a dynamic headspace scenario. So we're releasing the volatiles and the semi-volatiles from the product or from the sorbent tube. They are then transferred across onto a secondary focusing trap. This secondary focusing trap contains multiple sorbent beds inside there. The different sorbent beds effectively act to filter out the heavier hydrocarbons in the first bed, with the stronger beds capturing the lighter volatiles towards the end. The carrier gas itself and other unwanted interferences such as moisture are not retained on these sorbent beds and pass out the back of the focusing trap. At this stage as well, we have the ability to split off a portion of the sample. So again, if we've got a very, very high concentration sample, we don't have to send all of that to the focusing trap. We can split that off to either a split tube or a recollection tube. In stage 2, our sample is now transferred to the focusing trap. So now we rapidly heat it at about 100 degrees C per second and reverse the flow of gas through that focusing trap, something we term back flushing. So that allows us to get those heavy compounds and the light compounds back off the focusing trap to the GC. So this is kind of key, and the key to that very wide analytical range we have is the ability to do this back flushing. In this step as well, we're injecting to the GC. We also have the ability to split the sample as well. So again, we can use one or either of those splits as we need to. So we talked a little bit earlier about recollection, and let's have an example of what this can do for us. So what we're doing with recollection is the split portion of the sample. Rather than send that to waste, we send it to another sample tube so we can reanalyze it. What this allows us to do is, particularly with natural products, we can expect a very wide range of compounds, both in terms of their volatility, but also in terms of their concentration. So in this example here, we have a natural product which has some components at very high levels. So running with a high split allows us to inject those without overloading the GC and the mass spec, allowing us to quantify those large compounds. So for in this example, we've looked here at linalool, run with the split so it does not overload. But then we want to look at some of the trace components as well, because again, they may be small in terms of concentration, but they can be important in terms of flavor, profile, or scent. So we recollect the sample onto another tube, and then we reanalyze that tube under a different set of conditions. So in the lower example, we've run it with a lower split. So here the linalool overloads, but now some of the smaller components, we've picked out the 1-hexanol here, now become more readily detected and quantified. So this is the benefit. We're actually running the same sample, but under multiple different sets of conditions. So let's move on to some of the results we have. So first of all, we started off looking at the whole flower, and this is an example of a chromatogram taken with solvent extraction. So this is 80 milligram of the strain, sonicated in methanol for 20 minutes, and then we've taken 1 microliter of that solution and injected it splitlessly into the GCMS. So I've highlighted a couple of different regions on the chromatogram here. We have the cannabinoids out at 50 minutes, and then the region where the terpenes are between 10 and 35. Okay, so quite high recovery for the cannabinoids, quite low recovery around there for the terpenes. So let's now compare what that looks like when we use thermal desorption. So this is the same mass of flour placed inside the empty glass tube, heated to 190 degrees C for 5 minutes. And then we've actually run this with both an inlet and an outlet split. So whereas the solvent extraction was done splitlessly, this is done with a 93:1 split ratio. And if I just go back to the previous slide, compare the cannabinoids to the terpenes, you'll see that when we do this approach, we have a much greater recovery of the terpenes by using the thermal desorption. I've also highlighted down sort of around 5 to 12 minutes. This is the region where the light volatiles and potential residual solvents would come out as well. So by not diluting our sample, injecting all of it to the GC, we get this big volatility range and great sensitivity boost by using thermal desorption. So let's take a look at each of these regions in a little bit more detail. So looking in at the cannabinoid region, there's 13 potential cannabinoids that are identified, THC being the largest of those, and then also some of the other ones as well. So we've got CBC, CBN, and CBG in there as well as a couple of unidentified ones that couldn't be reliably identified from the libraries. So you can see like the CBL there is a very, very small peak. So again, we're picking up these trace cannabinoids. Also note that we don't see any of the free acids here, so we're getting almost complete decarboxylation. If we look at the light end of the chromatogram, this is the area we're expecting the most volatile compounds to elute. So here on the right-hand side, I've just pulled out some of the target residual solvents from the California methods. This is applicable more to vaping products as opposed to raw flour, so we're not really expecting to see much in this example. However, we do pick up both acetone and toluene to very, very trace levels, probably associated with handling. But because this is an untargeted analysis, we can look at the other peaks we see. So we've got things like dimethyl sulfide, acetic acid, 2-propanediol, hexanol, and some thiols as well. So there's some other interesting volatile compounds in this region as well. It's also worth noting that thermal desorption is a fully quantitative method, so it would be possible to calibrate by spiking liquid standards onto the thermal desorption tubes and building a calibration curve so that these compounds could also be calibrated. And then perhaps the most interesting region is the terpene region. So we have a whole range of different terpenes in here. Over 40 of them have been identified. We have a lot of coelutions in here as well. But certainly comparing it to the solvent extraction in the grey trace below, again, they're not shown on the same scale here, but just the amount of the terpenes that we're seeing, as well as there's also a loss of some of the volatile terpenes in that solvent extraction method. So solvent extraction isn't giving us the full picture here. On the right-hand side, this is just an example of some of the target terpenes that people are looking for. But again, there's much more information in there than this. So let's look, so why are terpenes important? Well, cannabis flower has been studied a little bit, but in terms of other high value crops, it's actually had very little research done on it, mainly because of its illegal status. But within that resin, there's lots of other different compounds besides the cannabinoids. Over 400 have been identified so far, and they can be classed into steroids, flavonoids, sugars, but terpenes are perhaps one of the most interesting ones. So those terpenes are produced from many plants and also some insects as well. And they're built from the isoprene molecule. So we have different classes in here, some terpenes and terpenoids as well. So why do we care about them so much in the cannabis world? Well, they impart these distinctive aromas and flavors to the cannabis. They're also thought to contribute to the psychological effects and the psychoactive as well, in kind of an entourage effect. So here what people have speculated is that the terpenes are interacting with other terpenes or with cannabinoids in the cannabis to enhance the health properties or the psychoactive properties of the cannabis. Most of the research that's done previously has focused on individual terpenes. So myrcene, it has an aroma profile, but also known to be sedating, relaxing. Limonene, good for stress relief, etc. But much less is known about how these different terpenes work together, and then also in combination with the various cannabinoids as well. So there's a lot of research going on into this area. So there may be 3 main species of cannabis, but then there's multiple different strains, possibly thousands based on these. And again, the growers can change the terpene profiles by engineering the different strains, and also in terms of the way that they're grown as well. So in order to identify the differences and the importance of this, it's important to have a robust terpene testing method that can detect everything down to these trace levels. So as an example here, so even 2 different varieties, or the same variety of cannabis sold under the same name, don't necessarily have the same chemical profile. Even plants with the same makeup can actually change that profile depending on how they're grown. And some of the work that was done up in our Toronto lab here was looking at cannabis, the blueberry kush strain purchased from a dispensary versus the same strain grown outdoors. And they looked at the different types of terpenes in terms of the overall class. And what we can see here is there's a massive difference between the dispensary versus the outdoor grown products. If we look in a little more detail at the specific terpenes that are seen, 4 replicates each of the outdoor grown versus the dispensary, you can see that the dispensary product has a far larger range of terpenes present compared to the outdoor grown. And this is kind of expected because the different temperatures, the growth medium, exposure to sunlight, the nutrients can all affect the actual end result in the product. So how do you test for that? Well, you need to have a good method that can detect all of these terpenes. And in fact, looking at the dispensary terpene, this is just, again, the sort of typical target list. Over 180 different terpenes are identified in that dispensary sample. So there's a lot more information there, a lot more that can be discovered from these samples. Moving on to some of the more challenging matrices. So we looked at CBD products, so vape pen liquid, a CBD containing oil, and then CBD containing gummies. So these samples can be quite hard to extract. They can be a little bit messy. So rather than place them inside the empty tube, we placed them inside a headspace file, and then we sampled them using the Mark's HiSorb high capacity sorptive extraction device. So you can see these on the top right here. So you might be familiar with SPME, solid phase micro extraction, where you have a thin fiber where it basically absorbs the compounds of interest out of the headspace. We've kind of made that a little bit more robust with the HiSorb showing here. So we have a metal probe, so very, very robust, and then we have a PDMS sleeve that sits on the end of that fiber. So we have both robustness and increased phase, which gives us more sensitivity. So the process is we take the sample, We place it inside the headspace vial. We place the Hyzor probe inside. In this case, we were just doing headspace. It sits then inside an agitator, which heats and mixes the sample. The probe is then removed, placed inside an empty thermal desorption tube, caps on, back inside our TD100 for analysis by the GCMS. And here's an example of what we saw with the vape pen liquid. So this was 50 microliters, heated to 50 degrees C, and we sampled for 10 minutes using the Hyzor probe. So again, from the chromatogram, we see a series of different terpenes in here, but nowhere near as much as the actual raw product, which is to be expected because often the terpenes here will be added to the liquid as opposed to being what's called full spectrum from the actual cannabis itself. So now let's have a look at the actual as consumed products. So can we sample the products after vaporization and combustion? Well, thermal desorption is used in a number of different international air monitoring methods. So for example, the EPA's TO15 method. So can we use that same sampling technology, the pumped sampling onto solvent-filled tubes, to analyze these? And the answer is yes. So this allows us to, in the first approach we've looked at so far, look at the raw product and see what compounds are present. And then we can sample after vaporization or after combustion and see the differences, see what's happened, any additional chemicals could be formed. So it's allowing us to analyze what the end user is actually inhaling. So the first example here, we're going to look at dry vaping from the vaporizer. So again, the experimental setup is relatively straightforward. So we have our vaporizer, we have our cannabis inside there. We connect the vaporizer to the Mark sorbent tube with a short length of tubing, and then we're pulling our sample using the Mark's EasyVox syringe pump. So a very straightforward sample. So we weigh out the flower into the vaporizer pods, place them into the device and preheat them. We are then taking 50 ml samples onto these sorbent tubes pulled by the pump, and we can switch out the tubes and do multiple pulls and get a profile of the sample. So we did this 5 times, and we actually weighed the tubes before and after sampling. So we're finding we're getting about 1.2 milligrams weight difference pre and post sampling on these 5 different tubes, and it was consistent across the 5 different pulls. Now looking at the results shows some interesting things. So again, this is the same strain and the same mass as we used previously with the direct desorption study. So in that first puff, the profile there for the terpenes looks very similar to what we saw when we analyzed the direct desorption sample. But interestingly, as we go through and sample more and more from the same device, the same cannabis, the profile changes in the terpene region. So as expected, it kind of decreases, but also the profile within those terpenes changes as well. So again, this is going to have an effect on what the end user for the experience is. It changes as we're actually taking the puffs of this device. We also use the same kind of technique for looking at vape pens as well. So here we're more interested perhaps in some potential contaminant compounds, related to the lung injuries, looking at the byproducts. So again, we're going to use the syringe pump to take the samples, except here, rather than just taking the sample directly onto the sorbent tube, because the vape pens can have some heavy oils, waxes inside there, which we don't really want to collect, we're going to use a quartz tube filled with quartz wool as kind of like a pre-filter. So that captures those heavier compounds. If that fraction is of interest, then that tube can be liquid extracted and analyzed by LCMS as well. So it still allows us to capture the information on these samples. The other area we can use thermal desorption is just for the ambient air monitoring. So if we are looking at what's present in grow rooms or smoking rooms or packaging areas, again, we can use the pump to sample onto the sorbent tube and see what's there. This example I'm showing here is from one of our application notes looking at incense sticks. So here we've sampled in the room while the incense stick is burning, and then again afterwards to see how these compounds decay away inside that area. So again, a very large volatility range, both targeted and untargeted analysis here to see what people are being exposed to. So as we come to wrap up now, we've talked about the different areas in green here, the direct desorption, the pumped sampling, and the sorptive extraction techniques. But there's other areas where the Mark's expertise and our sampling devices can be used here as well. So we do analysis with breath for the medical side. But again, this allows us potentially the ability to sample what's coming out of a vaporizer, but then also sample directly out of the patient or a customer's lungs to see what might be coming out of there. We have the Mark's microchamber. So this is a kind of a larger way we can do dynamic headspace. Again, very similar to the direct desorption we've shown, but in a larger sample. So here we could place larger pieces of sample. We've done work with the incense sticks where actually we had them burning inside the microchamber and seeing what volatiles were released. We do work with research groups that are looking at plant emissions. So you can imagine you could place a growing cannabis flower inside one of these sampling chambers and actually sample the volatiles coming out of the plant. You know, could we tell information about the optimum time to harvest based on the compounds that are released from the plant without actually harvesting it? So there's lots of different areas, again, getting the wheels turning about what we can do with thermal desorption in these areas. So in conclusion then, so the Marks offers ability for those in discovery, research and product development. You can look at knowns and unknowns in your sample and products. And what's in our sample? We can do things like competitive analysis. We can do product development. We can test different formulations. I hope I've shown in this presentation that it's an incredibly versatile technique. So with the same hardware, we can do a whole raft of different experiments on different types of samples. The recollection capabilities of the Mark system allow us to repeat analysis. So even from that one experiment, we can get multiple different runs and do this high-low analysis to look for both the high components and the absolute trace that's in there as well. Moving through to testing and routine analysis, we have a system that allows the ability to do high throughput with the 100 tube capacity. Now we've got quality control in there. It's a robust system and method compliant thermal desorption system with all the leak testing capabilities. So in summary, the Mark's solution allows us the ability to discover more from our samples and then deliver more to our customers through routine testing and analysis as well. So that brings us to the end of this kind of quick summary of the Mark's TD capabilities. So I'd like to thank everyone for joining us. My email address is there as well. So if you have any specific questions about what we've talked about, or if there's things you think would like to see us do with thermal desorption you think might be interesting for the market in general, please let us know. We're happy to help with that. And now I think we'll turn over to some questions.
Awesome. Thank you so much, David. As you said, it's time for our Q&A. If you haven't already done so, please type your questions in the question module that you see in the GoToWebinar control panel on the right side of your screen. All right, let's dive into a couple of these. The first question is, can I reuse the glass tubes used for the cannabis flower sampling?
Yes, you can. Yeah, so the glass tubes, once you finish sampling, the glass tubes can actually just be sonicated to make them clean. And yes, they can be reused again. So almost indefinitely for those glass tubes.
Fantastic. All right, next question. How many uses can I get from a sorbent tube?
Yeah, so for the sorbent tubes, the sorbents themselves last about 100 to 200 thermal cycles.
Fantastic. And this next question is about cost. How much do they cost each?
So this is another nice thing about the thermal desorption tubes is they're actually relatively inexpensive. So around $50 per tube.
Awesome. I think that is it. I want to give a big thank you, David, for joining us for today's webinar. As a reminder, as a registered guest, everyone will receive an email within the next few days with a link to the recorded webinar. At the end of this webinar, a short survey will appear. Your answers not only help us understand how we are doing with our webinar program, but help us understand, create a future roadmap for these webinar topics. We encourage you to visit lqa.com/resources for future webinar details and to access our library of recorded on-demand sessions. Thanks again, everybody, and have a great day.